Welcome to today's Postgres conference webinar, PostgreSQL Auto Vacuum Tuning, Lessons from the Field. We're joined by Jessica Sharp, Database Engineer at Podium. Welcome, Jessica. Today's presentation offers guidance on identifying good practices around monitoring auto vacuum, how to approach tuning, how to avoid the most common pitfalls that Jessica sees during tuning exercises as a consultant in the field, including a high level of what auto vacuum is doing and why, how to monitor and analyze auto vacuum performance, how to identify the most common auto vacuum based database operation interfaces, and a high level of guidance on putting the above points together to improve auto vacuum efficiency. My name is Lindsay Hooper. I'm one of the Postgres conference organizers, and I'll be your moderator for this webinar. So with that, I'm going to hand it off to Jessica. Take it away.
Thank you. Thank you everyone for joining us today. I know this is lunch and post-lunch for a lot of people. Really appreciate you logging in for this. If you weren't aware, this webinar series, not with me as a presenter, but it does continue through December 31st. So if you haven't already seen the events page, check that out and register for some more. So today we're going to be talking about Postgres auto vacuum tuning. I am in the field. I am a consultant, so I see a lot of different environments, a lot of different issues. And I thought, hey, let me share some of that, because a lot of it I find myself repeating to customers over and over and over and over again. You'll notice at the bottom of all of my slides, there's the little Twitter icon and my Twitter handle. That is included because that is embarrassingly, but truly the easiest way to get a hold of me if you have any follow-up questions, and if we run out of time or something, or if you think of a question later, just shoot me a message on Twitter. Before we actually start talking about the fun stuff, I do have a couple of my own housekeeping items. I do live with some angry birds. They don't actually look like this, but one of them really thinks he does. Yesterday, they all sounded like little velociraptors and would not stop. Today, they're in a little bit better of a mood. We'll see. They're volatile. They're great. I love them, but they're crazy. They also so if you do hear them in the background, don't panic. You're not having audio issues and you're not crazy. There are genuinely a flock of birds in my house. They also attract a lot of wild birds. So if you hear other species of birds, sometimes the magpies get a little bit upset and come to the window and scream if they can't hear my birds. So it happens. Although the birds are in the other room, we shouldn't have any issues. My other thing, there we go. Disclaimer, I used to be an Oracle person, so this is my version of my safe harbor statement. I'm going to show examples of parameters in here. My point in showing them is to show you what parameters to look at and generally what they are. Do not match my values. Those parameters, I put in the values to show examples. They were pulled from a database I have in my personal lab, well, from a cluster. But first of all, I'm constantly breaking that database on purpose. Don't entirely remember what exercise. It's been a couple of weeks. I pulled these fresh, and it's been a couple of weeks since I've looked at that database, so I don't remember what I had broken. The values are not going to be advisable. And obviously, don't make any changes directly in production, but I wouldn't even advise applying my values on these parameters in a lower, non-prod environment. Do your due diligence, look up the parameter that I give you, take the advice that I give you as well as your own research, and then come up with the value. There's one exception to this. The auto vacuum on, that's the one you can copy and paste. Your auto vacuum should be on, unless you can make a very strong case for it. And I have yet to meet anybody who has convinced me that their auto vacuum should not be on. My one final housekeeping item: on some of my slides, you'll see this picture icon in the bottom right corner. This means that there may be some more detailed information in my speaker's notes. I will try to hit everything, but sometimes my brain goes off in these little tangents while I'm doing research for these things and or for real projects. And on a couple of slides, I have included those tangents in case they are interesting. I've also got links to further reading on a few of these and other resources. Okay, so a few assumptions that I'm gonna make. I'm assuming if you're here and want to tune your auto vacuum process, I'm assuming that you're running at least Postgres 9.6. If you're not, you got some other, we need to talk about some stuff. A question that I get a lot is, has vacuum always been around? Is vacuum a feature? Is auto vacuum a new feature? No, vacuum has always been around. Auto vacuum has been around since 2005. This is because, so both vacuum and auto vacuum have been around because of the Postgres concurrency control model. In database versions 9.6 and newer, and this is the reason that I'm making this assumption here, there are helpful system tables and system views to assist the DBA in gaining insight into what is going on. Tuning without these has extra challenges. And also, if you're not on at least 9.6, you really need to upgrade. I know that's annoying. I'm that person who's always saying upgrade, upgrade, upgrade. But 9.5 is, if you didn't know, no longer supported as of February 11th. That doesn't mean that your consultants and your DBAs can't fix things. Obviously they can, but if you find a bug or if you run into a bug in the Postgres code, the development group is not going to help you. It's not supported. And on that note, support for 9.6 ends this November. And in my speaker's notes here, if you don't have a link for the versioning page with the release dates, a little bit of information about the Postgres release cycles, there is a link in the speaker notes, but it's pretty easy to find on the Postgres documentation page. All right, so what we're here for. At any point, if you do need to quickly, if you're brand new to Postgres and you need to reference the Postgres docs, it's just PostgreSQL is the official. Okay, so vacuum. My non-DBA friends and my non-Postgres friends, and I actually should say just my non-Postgres friends, because my Oracle friends make fun of me for this too. Anytime I talk about vacuum or auto vacuum, I go, you vacuum your house. Why are you vacuuming your databases? And why are you so angry when we say turn it off? So if you don't know what the vacuum does, it actually does, it covers a very complex set of maintenance activities. But what we're focused on, because what most of my consulting time is focused around with vacuuming, is removing the dead tuples for each page of the table files, or freezing them, and we will talk about the difference in a few minutes from now. And we'll also talk about, just to hold the thought on what a dead tuple means. There are two major kind of styles of vacuuming: concurrent vacuum. This is where your transactions can still read from your table. This is the default this is what auto vacuum, the method that auto vacuum calls. Full vacuum actually defragments the tuples on the whole table file. So you actually get the space back, versus concurrent vacuum. You don't necessarily get you can't see reclaimed space with this. We'll talk about the complexities of that in a minute too. With the full vacuum, so auto vacuum does not do a full vacuum, and this is good because during a full vacuum, transactions cannot be read from the table. So what is auto vacuum then? Auto vacuum is the vacuum process automatically launched It's not actually magic. It's based on a bunch of parameters that we'll talk about soon. But first, we need to understand a little bit, about why it exists. And we need to go back to that little thing called concurrency control that I mentioned earlier. Now, Postgres uses the multi-version concurrency control model. So it kind of sort of like, yes, you get another version of the tuple after, if a transaction goes in and updates it or deletes it, instead of, actually updating, it creates a new one, and that's the next version, and that's what's visible to each user. Now, if that's a little bit much, you don't need to get super deep into the concurrency control on how it works. It is helpful to know the high level, so that's what we're going to cover. But we are also, we're going to come back to that, but we're going to look at a few kind of things to keep us on track here. So the maintenance work mem parameter is the only not vacuum or auto vacuum parameter that I'm going to mention. This is important. So it is what it sounds like. This is your bucket of memory that you're allocating for all your database maintenance processes, auto vacuum included. Now, if you look at the you look through your Postgres, especially if you've the PostgreSQL.conf file, and especially if you've just got like a default configuration or you haven't tuned this yet, you'll see that there's an auto vacuum work mem, and you'll see it's -1. I've had that scare some people. They go, oh my gosh, we have no memory allowed for auto vacuum. It's -1. What does that mean? So what that means, the auto vacuum always takes out of the maintenance work mem bucket. When auto vacuum work mem is set to -1, what this means is it gets to use the full maintenance work mem area. I don't personally recommend that. You'll want to set the auto vacuum work mem if you're having CPU issues. You'll want to set that based on the number of auto vacuum workers you have, that you expect. In addition to that, I like to confine that to no more than 80% of the maintenance work mem, and that's really aggressive, in my opinion. If you have things like backups that take a lot of memory, also, I would decrease that. But just look at all of the maintenance activities, look at the windows where auto vacuum tends to run. I know that's hard to predict, but you will want to at least look at it, because you could run into resource contention. It's pretty hard because there are a few other limits on auto vacuum, but do keep that in mind. Okay, so we've got to go back to quick note about the concurrency control model. Now, when I said that you've got multiple versions of itself, and this sounds crazy because I've had a few people, well, especially people brand new to Postgres, go, oh my gosh, why would we keep multiple versions of itself? The database is going to be huge. I've done a lot. I spend most of my time doing Oracle to Postgres migrations, and usually the footprint is not exactly the same, but it's ballpark, plus or minus about 20% with proper tuning of the disk space footprint. That's not accounting for ASM with your disk redundancy there. That's a whole other discussion, but the concurrency control model is important. What it's there for, essentially, the very simplified version, is about allowing efficient access for all sessions while maintaining strict data integrity. So this is specifically to address when 2 or more sessions try to access the same data at the same time. The multi-version method of doing this means that there's transaction isolation. So reads don't block your writes, and writes don't block your reads. And I've got a link into the documentation where it talks about that a little bit more. And I've also got a link to my favorite book that talks about this. And that's just the Postgres administration cookbook by Simon Riggs and Gianni. I think they're second quadrant. So if you're really, really, really concerned about it, the default transaction isolation level in Postgres is called read committed. There are 3 possible ones here. You can override read committed if you have a specific transaction that you want to behave differently, especially if it's a repeatable transaction. You can change this at the transaction level. So read committed means a transaction can only see rows that were committed before it began. So if I went in, said begin, updated a bunch of rows, and another user was logged in before that, before I hit commit on that transaction, they wouldn't see my updates until I committed. Repeatable read is another one of the options. What that means is all statements of the current transaction can only, you know what, I think I have this backwards. I think I tested this once, like a couple days ago, and read committed actually let me see, if I remember correctly, it actually let me see the updated results before I committed. Repeatable read, I think, was the one that gave me the old row or rows until the commit was hit. So 2 ways to check this. If you're curious, just show default transaction isolation, or in the conf file, check that your logging collector is on. It really should be, but your log statement level should be all. Okay, so how in the fudge Pop-Tarts does the database know which version? Let's say we've got like 10 people updating the same stuff at the same time. How does it know, and how does it keep track of which version I, the user, should actually see? To oversimplify things, it creates a map for each of those blocks in the table file. And I promise this is relevant to the vacuum. I promise. What is going to happen here is each transaction is going to get assigned a transaction ID. And when you update a row, it's going to assign, it's going to say, okay, that was this transaction. And it's going to go and say, okay, new transaction ID, because now that's been updated, and it's going to attach that to a new block, so multi-version. And that number is just going to keep going up and up and up on the transaction ID. So this is a 4-byte number. It is finite. This is why vacuum saves the day, because it doesn't actually modify. Explaining this is always tricky, and every time I do it, I pause and I'm like, is this really the best way to explain it? So here we go. If it doesn't make sense, please, please, please ask questions. I will clarify. I know it's confusing. So when it modifies, when you do an update to a row and it writes the new row essentially and gives it a new transaction ID, it marks the old one as not visible. Doesn't actually remove it from your table files. It's still there, it's just marked as invisible. So it's like driving with the GPS. And well, the GPS that you don't even know is there. And that's why I've got a picture of a map. But it's also like having your car automatically know about stoplights and stuff too. it's pretty cool. Because it'll tell you, hey, stop, that row is not visible, and it'll redirect you to, this one over here. So what happens to all of the rows or tuples that are there that got updated or, well, marked as no longer visible to the user? That's the phrase I'm going to go with because that's the most accurate. Even though to the user it feels like it's the same row, it's the same one thing, it's really not. In order to kind of flag to vacuum or auto vacuum, the hidden rows get to reach a certain age. You can update that row so many times, and it can have X amount of versions of it that are not visible. And this is referred to as freezing. These are when it passes a certain threshold. So not all hidden rows are frozen, but ones that are older than, and we will get to that parameter, Autovacuum will mark them as frozen, never to be updated again. So it'll only update the non-frozen or the most current one. This and the hidden ones, that if you need a Google search term, those hidden, the tuples that are marked as hidden by the map, so to speak, not a technical term, but that's how we're going to talk about it. That's called bloat, and that's something you want to keep track of. When you're querying your system catalogs, to make it even more confusing. So remember, bloat is dead tuples. That dead tuples is going to be what's going to come up when you're querying your system views. That's how you identify your bloat, and that's how you know if Autovacuum is keeping up and or vacuum if you're manually kicking things off. So how does Autovacuum know when to vacuum? Postgres controls Autovacuum with, there are over 40 individually tunable parameters. And those are all going to be, of course, in the PostgreSQL conf or the included configuration files. So they're set at the database cluster level. Goes without saying. So something I used to say in this presentation that I recently learned was an oops, nope, that's not exactly true. I used to think that you could only adjust auto vacuum or vacuum through those parameters. Therefore, cluster wide was as granular as you could get. That is not true. I have learned, I have made my life a little easier. You can set the auto vacuum parameters for a specific table or a group of tables, what you want to look at in the documentation, and what I'm not going to talk about in this presentation because they're more or less the same. It's just your method of setting them is going to be different. What you want to do is you want to look up and adjust your storage options on your table definition. All right, so auto vacuum goes through 3 stages. It scans, then it actually cleans up. It's like your garbage collector. And then it finishes the cleanup and it updates the statistics and the system catalogs. I'm going to make a note right here, and I'm going to call out that when it's cleaning up with the concurrent vacuum, just like a normal vacuum, it's not removing the hidden or frozen blocks from the table file. What it's doing is it's going back and it's saying, hey, we can reuse this block space basically to kind of put that in I mean, a lot of things in here are going to be simpler. Like I'm going to give you the simpler version than what it is, because otherwise this would be like a 4-hour presentation. And then the next step is there is index vacuuming involved here as well. So please maintain your indexes and keep track of unused indexes because that'll bite you. And then it'll go through and update the system catalogs so that when you're monitoring or checking on it, you'll have updated information in there. Okay, so first parameters first. We're going to start going through the big auto vacuum. I'm not going to go through all of them because, like I said, there are over 40, and there are also redundant. Well, they look redundant because there are just vacuum, and then there's a set of auto vacuum. We're only going to talk about the auto vacuum ones. So first of all, if auto vacuum is set to on, and it really should be, then auto vacuum wakes up every so often to decide whether to run a vacuum. And again, that's not a full vacuum, that's the concurrent vacuum, or analyze that stage, or both. And that kind of that period that it sort of sleeps for before it decides to wake up and decide whether to vacuum or analyze or both is referred to very cleverly as the auto vacuum nap time. 1 minute is aggressive. I believe that's the default though, but that is something that you can look at. And then your auto vacuum max workers. I don't think the default is 4. I don't know what the default is, honestly. So it may sound like, oh, auto vacuum is struggling, let's just add more increase the max workers. Not actually a great idea. Remember that this does take up system resources. It is IO heavy and it is memory intensive. It can be. So before we talk about going off of resource usage, let's address the freeze age based thresholds. So to avoid auto freezing and possible row corruptions, I haven't personally seen that due to this yet. Usually that's a hardware issue, but I hear from colleagues that it is possible. Your vacuum freeze min age, that is the cutoff age. And when I say age, I'm talking about number of transactions that the vacuum process should use to decide whether to freeze row versions while scanning the table. So it's not going to reclaim that space, that block as usable. It's just going to say, hey, this is a frozen row. The most this didn't come out of my lab. This is, I think, is the default. This is for a moderately busy database, but you don't want to set this to less than a few hours worth of transaction IDs. And you also don't want to go higher than half or 50% of the auto vacuum max freeze age. What is the max freeze age? This is the age, again, in the number of transactions that will trigger auto vacuum to vacuum a table to prevent, I suddenly cannot speak, transaction ID wraparound. So if your transaction IDs are about to roll over, that's what that is. So that is definitely one set of concerning parameters that you want to look at when you're tuning. But the other big thing to understand here is the IO heavy issues. Autovacuum, I'm trying to hit next and it's not cooperating. Autovacuum does participate in IO point based vacuuming. What this means is it calculates IO points so that your disk IO doesn't go absolutely bonkers. It will run until it acquires a certain number of points defined by you if you choose to adjust the defaults. If you don't, it's the defaults, and these are the default values. So your vacuum cost page hit, that's the cost of vacuuming a buffer that was in the shared buffer cache. This is only 1 point, not a crazy big deal. A page miss, it is what it sounds like. Cost of vacuuming a buffer that had to be read from disk. And then the cost of page dirty, so the cost of modifying a buffer that was previously clean. This is 20 points. So by adjusting the values for these and reassigning points, I wouldn't do this. This is a little bit absurd, but if you wanted to say, it's so absurd that I can't even say it. So let's say you wanted there to be a higher penalty for vacuuming a buffer that is in the shared cache. You could set that to like 20 or something, and then vacuum is going to stop a lot sooner when it's doing normal activity, because most of your vacuuming activity should be buffers that are in shared buffer cache. So that's going to override any other settings that you have. So if the auto vacuum runs on a table right after vacuuming, this kind of ties into IO and memory. What happens is Postgres scans a target table. In that scan phase, it scans the table to build a list of dead tuples, so ones that are not visible to the user and not going to be updated again, and to freeze the old ones if possible. What it does is when it scans, it makes a list of dead tuple. What does it do with that list? How does it keep track of that list of dead tuples and frozen tuples? It actually stores that list in the maintenance work mem, or it's allowed to store that much in there. However, whatever your maintenance work mem is set to. Unless you have the auto vacuum work mem set, then that's it. That's your limit. If it can't fit all of those, the list of dead tuples and frozen tuples in that memory, it'll do what it can and it'll run again. Okay, so other thresholds. I have the analyze scale factor and the analyze threshold before the vacuum scale factor and the vacuum threshold, because ideally you want to analyze before you vacuum. It normally does, but you could override that by getting these backwards. I'll pretend I've never done that. So what the auto vacuum analyze scale factor does, kind of a not necessarily self-explanatory, although maybe it is. This specifies a fraction of the table size. So your activity level, you'll want, in this example, this is 10% of, updates or whatever to the table. And it says, hey, watch out for that threshold of changes, and then add that to the threshold value. And then we'll decide whether to trigger and analyze. So if you wanted to trigger analyzing more aggressively, you would lower either the scale factor, the analyze scale factor, the analyze threshold, or both. So here in this example, the analyze threshold is set to 50. This means that let's say I update 50 rows in my table. There we go. I've met the analyze threshold, except not yet. In addition to updating those 50 rows, I also need to update 10% of the table. That's my scale factor. Once that's achieved, then Autovacuum will analyze. So the vacuum scale factor, back up, because vacuum also has a scale factor and a threshold. No, it doesn't. I'm sorry, that was dumb. The Autovacuum vacuum scale factor works the same way. 10% of activity in the table plus the Autovacuum vacuum threshold, which in here is 50 row updates or deletes, will trigger a vacuum. And again, this is not a full vacuum, so you're not logging reads from the table. This is the concurrent vacuum. And you can see why you want to be careful. I am very, very, very guilty. Here's a pro tip from the field. If you wear glasses or contact lenses or something, or you've been working crazy long days and you're exhausted, double check that you are setting what you think you're setting. I have mixed up the vacuum scale factor and the vacuum threshold with the analyze scale factor and the analyze threshold. And for a little while, we were confused about why we weren't analyzing before we were auto vacuuming. That was a fun troubleshooting exercise. Just be careful. I think my excuse that time was like I wasn't wearing my glasses or something, and I was looking at my second monitor, which is further away than my smaller and further away. Doesn't help anything. So another thing here, when you're looking up what the thresholds are online, there is an equation that comes up over and over and over and over again. And yes, I'm bad at math, but I don't get this. They will multiply, they'll take the scale factor and the threshold and multiply by the number of tuples in the table. And I don't know, it always gives me a weird number, and I'm always like, okay, that's nice. So I just look at these two. So this is my formula. Maybe I'm wrong though. Do the math for yourself. Like I said, I'm pretty bad at math. Ironically great at spelling, despite the engineer stereotype. But I have seen a few instances where both the Autovacuum vacuum threshold and the Autovacuum vacuum scale factor was reached, and it didn't necessarily trigger an auto vacuum. And that's because there were some other things at play, like the nap time and the I think like the cost delay or something was set weird in that database. But it's those numbers or greater when other, your other limit throttles on auto vacuum have been satisfied, then as long as the row activity or table activity is greater than these, you're good. All right, so overall, from a practical perspective, what are we doing? Are we just going in and setting parameters willy-nilly? Sure, not willy-nilly. Part of it is, adjusting parameters. Our big picture goals that we want to keep in mind are, in general, we are controlling and refining our automatic database maintenance. I used to say that Autovacuum is my hero and Autovacuum can just handle it. Trust the Autovacuum. I have recently adopted a few databases as a consultant and at Podium that I'm fairly confident that Autovacuum has been tuned to the fullest extent possible. I think we're wasting our time by going through any more. I mean, we always want to monitor, sure, but I don't think that changing any more cluster parameters or the table, in the storage options. I think we're at our limits there. So we've, in my opinion, done our job with controlling automatic database maintenance. We are going to have to work some manual vacuuming into that. And that is something that I used to be strongly against. I thought, no, auto vacuum is this cool thing. Let it do what it was put in to do. But sometimes you need both. Use your best judgment. So when you're looking at, is auto vacuum even, is it keeping up? How do you know when you've reached the optimal control over all of your automatic database maintenance, but you've still got people calling with issues? You want to, your things that you're trying to do, you're trying to avoid the auto freezing. I've worded the next line here, remove issues that cause bloat. I've worded it that way rather than saying remove bloat, because number one, you're never going to eliminate all your bloat unless we're talking about a database on your local machine that never gets touched other than you messing with the infrastructure side. And because I want to keep an open mind, and this is really challenging in some environments, sometimes you can help the auto vacuum by, don't tell the developers that I said this because they will come after me, but changing code sometimes really does help. I had a database last fall that, and frankly, it was 9.5. So there was another layer of challenges, and I'm sure some of them were directly related to that, but they really just needed to change their code. They were updating rows like without reason. And when I say that I'm being nice, I'm kind of salty about it. What they would do is they would open these really long running transactions and make the same row over and over and over and over again, and they would just hammer the database, and then not understand why the indexes aren't as good as they could be. So there was index tuning that they were like, why do we have to do this? And then they didn't understand the impact that was having to the auto vacuum, and they didn't understand why auto vacuum couldn't keep up. Well, So that's why I worded it that way, because I want to be inclusive and I want to, don't limit yourself on ideas as to what could be causing your bloat. Think creatively with that. You also do want to remove old prepared transactions. You want to maintain your indexes. You want to be aware of and have a plan to remove your unused indexes. And as with any database maintenance activity, you want to plan. Hope it goes without saying, don't change anything in a production environment without testing it in a like for like non-production environment. And I know everybody's probably rolling their eyes right now. But if your things like your memory available on the machine and work mem and all of that's not as close as it possibly can be, and if your tables are not structured the same and your queries are not the same, you're only going to get so far. You're going to hit unexpected things in production. true with anything, but also Autovacuum. If that was too much, and if you've got an emergency or you know Autovacuum is not okay, if you can change your code, do it. If it's not too late, you want to really be clear about how much bloat you can tolerate. Like I said, you're never going to have a database that doesn't have bloat unless it's not a used database and it's, you know, your local one. So you'll want to do, if you're not already, and I hope you are, but do regular performance benchmarks and baselining so that you know at what levels of bloat does your performance start going down. And that's not just database, that's your server too. You want to be keeping track of your disk IO, because if you've already got a high level of disk IO and you run Autovacuum, that's going to increase that. I like the approach of be more aggressive. That's my personality. If you want to do that, then you want to lower your thresholds. I don't remember why I've called out the Autovacuum scale factor specifically right here, but you'll want to look at basically all of these. Actually, these are the highlight of the 40 that I usually look at. But you'll also want to be aware of when this is too aggressive, because Autovacuum is, there is some resource overhead with it. Don't be afraid of it, but plan accordingly. If you are struggling with the monitoring aspect of this, let's say I've had a few where they didn't actually have a formal monitoring system or any sort of monitoring tool in place. They were running their own queries. They were scheduling them and documenting the output of those queries, either in an Excel or a Word doc, and they were reporting that every hour or so to management. Here's an alternative. Set your log Autovacuum min duration to 0. Make sure you've got space wherever you're storing your database logs. Setting that to 0 will log all Autovacuum activity, and then you can, and of course you'll want to look up what the other logging parameter requirements are, but run that against something like pgbadger, or just scan through to do, postmortems or whatever. But that, yep. So check the logs, which maybe I should have opened with that, but here we are. So, okay, so with that, thank you for your time. Thank you for listening. We're going to go ahead and get to questions.
So we got about a handful of questions, and I figure we should just start from the top.
Sounds good.
Does Postgres have flashback feature like Oracle?
No, it does not. The closest you're going to get to that, short of, don't hate me for saying this, short of doing a recovery on your whole cluster, is to, if you have a set of transactions that you might want to roll back, you set your transaction isolation level to read repeatable. That's the closest you're going to get to that, but it is not like for like, so no.
Great, thank you. Can you please elaborate on quote, update statistics? What statistics are we talking about?
Good question. So those are your general database statistics, and like for the query planner, and just overall statistics.
What time and state does Autovacuum start?
So Autovacuum will not start at the same time. Like it's difficult to predict unless you have some historical data on when it's been running on your tables. But even then, unless your workload is very predictable, the closest you're going to get to knowing when Autovacuum needs to run is by knowing what those thresholds are and scripting out some sort of monitoring. I like to plug it all into Grafana. That way I get visual representation on it. But you want to know when you hit those thresholds, or at how far away those thresholds are based on your workload. That's really the only way to know when Autovacuum is going to start the vacuum processes unless you're manually vacuuming, in which case it's not auto vacuum anymore.
What is auto vacuum nap time?
So that is the wait period. Let's say auto vacuum just ran all of the available workers, and it's done vacuuming. It's not going to immediately start analyzing and vacuuming the tables that meet the criteria next. It's going to sort of kind of stay asleep for a little while, and that's what that nap time is. That's particularly helpful if you've got a table where the list of dead tuples and frozen tuples didn't fit in memory, and so vacuum will have to run again. It'll definitely wait and take a nap before it kicks off again.
Great. Doesn't the times scale factor need to be multiplied with the amount of tuples in the table?
That's everything I found includes that in that formula, but the way that I calculate my percentages sort of does that for me. So it probably depends on how you're calculating your scale factor, and if you're keeping it as a percentage or if you're literally calculating that against it. Well, yeah. So, okay, now that I'm thinking through like I said, sorry guys, I am bad at math. When I determine the literal value for my scale factor, I did not realize that until we got this question, but I am multiplying by the tuples in the table. So yes, short answer, I apologize.
Great. If I have an AWS RDS instance with a max disk read of 100 MBs a second, what would be wise to limit the max disk read for Autumn Vacuum to prevent impact on queries?
So in addition to monitoring your CPU on that, you'll want to look into the IO points, and that's going to be your cost page misses that you may want to test this and do some research first, but you may want to consider increasing the points for that. That way it tolerates, it'll sort of limit how much it runs based on direct disk reads that it's doing.
Wonderful. There are a ton of questions, and since we started this, they kept coming in. So we have about another handful now. How do you recommend changing the auto vacuum threshold parameters of large tables?
So for large tables, keep an eye on your indexes. That's something that tends to get forgotten. If your cluster-wide parameters are not sufficient, if they're not aggressive enough, but you don't want to make auto vacuum aggressive for the whole cluster, you want to focus on a set of large tables, change the table definitions, alter the storage parameters, and increase the aggressiveness of auto vacuum specifically for those tables using those storage parameters.
Wonderful. What are some techniques for measuring bloat?
Just query and I have these written down. I'm terrible at memorizing system catalogs, but there's a system catalog on your table. It'll actually show you dead tuples. So just look up how to query dead tuples on per table and keep track of that, because that will be your big easiest giveaway.
Okay, 3 more. How does auto vacuum affect query execution plans?
Well, that's a good question. If your auto vacuum isn't keeping up, your your query plans aren't going to have the most current or best statistics. Therefore, they may not be as efficient as they could be. Also, if you are auto vacuuming regularly and efficiently, and it's tuned to the best that it can be, your indexes are also going to be a little bit more helpful to you. It all comes back to those statistics that auto vacuum needs to update.
Great. Two more. Similar to Oracle, is there a way to collect view database table statistics periodically, assuming it assists in query performance?
That's a really good question. Coming from Oracle, that was one of the things I missed a lot. It depends on your monitoring tool. You may have a monitoring tool that has a plugin built in to do this for you. If you don't, my kind of cheat, my workaround is to create my own queries and my own procedures to collect the data. The PG stat tables are, to my knowledge, dynamic. So what I'll do is I'll query them periodically and write them to another table to keep for historical analysis. I also, and because I'm a consultant, this really depends on if I can talk the customer into logging everything or not. But if you have the logging levels set appropriately, they're pretty easy to look up and understand. Then you can do log analysis with something like PG Badger or whatever other tool you've got. But I like PG Badger, so that's the one that came out of my mouth.
Wonderful. And our last question, I apologize if we didn't have time to get to yours. Happy to follow up at a later date. But how do you vacuum without downtime or outages?
So make sure that your vacuum, well, so first of all, you'll want to do auto vacuum. You'll want to let auto vacuum do its thing. That's the easiest way. Tune it accordingly. But if you can avoid vacuuming manually, I would. At least avoid a full vacuum if you can. That's not always wise. Sometimes you have to take an outage. That's where I like to take advantage of maintenance windows. So if you don't have any upcoming maintenance windows, or you have a very high, 4 nines or 3 nines even, and really can't take that outage, really focus on getting auto vacuum working, or redirect traffic to a standby or something so that you can do what you need to do with vacuum.
Jessica, this was fantastic. I can't remember the last time we had this many questions on a webinar. So thank you so much for bringing such engaging content to the Postgres Conference webinar series.
Yes, I really appreciate the questions. If I didn't get to your question, feel free to just ping me on Twitter or LinkedIn or somewhere.
Awesome. I'll also include your Twitter handle in the follow-up email with the recording. So with that, regardless of where you are, if it's morning, evening, afternoon, I hope you have a wonderful rest of the day, and I hope to see you on future Postgres Conference webinars next week.